Good morning, good afternoon, everyone. Thank you for joining us for this timely webinar on running realistic load tests. This is the season for load testing. We're very happy that the interest from our customer base has been very high. Today we have a very distinguished guest, Lino Tadros. He is going to present to us based on his more than 10 years of experience working within Microsoft Framework first and then a bunch of other technologies, doing load testing consulting projects, training, and leveraging his other experience. Lino is a chairman and CEO of Falafel Software. Falafel is a key partner of SmartBear. They deliver consulting and training for our products. Apart from that, Lino is a most valuable professional with Microsoft for 9 years running. Established technical speaker. He's a former member, a key member actually, of the Delphi and C++ development team at Borland. Worked with a lot of projects with major companies, and last but not least, he's the best trainer ever that we had on SmartBear Test Complete. Based on his experience in web technologies, various components, rich internet applications, we expect to have a very interesting conversation today. A little bit about myself, but I wouldn't detract from the subject matter or our main presenter. I'm Sergey Sokolov. I'm Director of Product Management for Test and Performance Tools at SmartBear. In this position, I'm responsible for performance and load testing. And I'm very happy to host this webinar to share the knowledge that we have within the company, as well as leverage your knowledge as the audience with answering your questions, of which we actually had a lot. So thank you so much for starting this webinar. So as the goals of today's webinar, we really have to answer your questions about load testing. It's a somewhat unusual webinar for us. We asked the participants to submit their questions, and we got a ton, which indicates that there's indeed very high interest in load testing as a practice, as a methodology, in the technologies involved, in various pitfalls and success stories and approaches. So based on your questions, we will try to give you a realistic view on load testing, to the extent, of course, that our experience permits. Among the various topics that we will cover, we'll also explain the difference between different kinds of performance testing, because people frequently use the term load testing, but it doesn't really cover the spectrum of the potential tests that you could set up meaningfully to assess the performance of your application. So we'll start with the basics. Unfortunately, there were actually a number of people in the audience who submitted questions specifically targeting basics. So we thought that it would be very relevant to go through the process of load testing, the key components of a load testing solution, what should be measured in terms of the parameters of a web application client, server, network, and so forth, what's important to pay attention to and what's not as important to pay attention to, because with respect to load testing, you can acquire a lot of data, and of course the more data you acquire, the potentially the more confusing the whole picture becomes. And the mastery in load testing is to actually segment that data and focus on the very key that really allows you to assess and potentially improve the performance of your application. We'll also cover what tools are involved in measuring performance and scalability. Not obviously with the goal to cover the entire industry, but to give you some alternatives between, let's say, open source and commercial tools. So, Lino, I think that's a perfect question for you to start. What is load testing? What is it comprised of? What kind of tests would you want to consider when you say load testing?
Excellent. Thank you. Good morning, everybody. It's a pleasure to be on this call with Sergey and the SmartBear team, and I'm really happy to be able to share with you our experience with load testing using a lot of different tools in the industry for the last 10 years that we have been doing this professionally here based on Falafel software. To start with, I wanted to answer some of the questions that tons of them came in regarding performance testing and what's the difference between that and a load test and a stress test. A performance test, folks, is about determining and validate speed of an application. Usually it's made based on a single user just to start with. You just want to find out how your application, whether this application is an HTML, HTML5, a Flash application, a Silverlight application, or whatever it is on the server side, how does it behave? Because you cannot start load testing an application that doesn't even work for one person. So you want to make sure that the whole thing is working correctly first, and the numbers coming back make sense to you. Once you actually have that performance test executed and you're happy with the performance, you can now start load testing this application, seeing how it behaves under 10, 20, 100, 500, 1,000 people hitting these servers at the same time. That's a load test. And finally, there is always something called a stress test. And a lot of people get confused about what a stress test is. You don't expect a stress test to succeed. You actually want it to fail. The idea behind a stress test is that when it fails and you know that you can bring the application to its knees by maybe hitting it by thousands of people or a very high CPU use or a memory problem, you want to find out how graceful is your application going to exit or cause exception handling. You do not want to get into a total crash with 500 errors. You want to make sure that you have exception handling done on a stress test level. In case that scenario happens, you will be able to deal with it in your application. The web application performance, it's all about responsiveness, throughput, and resource utilization under a given workload. This is very, very important to understand here, folks. The responsiveness is measured based on a single client. Because like I said, you cannot load test something that doesn't even work for one person to start with. The throughput and the resource utilization are measured in terms of the whole system, all the clients. This is not a one client only. You cannot get the throughput and the resource utilization based on that. And there are a lot of tools out there that will help you create virtual users, whether 50, 100, 1,000. We will be talking about that later on as well. The apples-to-apples comparison for performance-based on workload is very important as well. I've seen a lot of companies, for instance, try to create different tests, but they are not apples to apples. They're trying to actually do something on a machine that doesn't have much memory and then compare it with a completely different test that has an 8 CPU, 16 gig of RAM, for instance, and expect the same results. So you have to be making sure that your tests are identical regarding hardware and software, not just software, to be able to tell if your performance test is logical or not. The web application scale. Yes, go ahead.
Lino, I just wanted to draw attention to some of the concepts in the previous slide, because responsiveness can be thought of in kind of many different dimensions. It can be how fast a server responds. It can be how fast the client sees the update based on the server response, whether the update comes at all, because with high loads, obviously you can get in situations where you just don't get a timely response from the server, or it comes after, I don't know, 5 minutes. And of course you can have divergence by content, right? If part of the system works correctly and part of the system lags, then you may have kind of a mishmash of data. Can you give the audience some sense of where the responsiveness actually needs to be assessed?
Absolutely.
Is it
Thanks.
the server side? Is it the client side? How do they sort it out?
Sure, absolutely. As long as you concentrate on what exactly you're trying to measure. There's so much stuff going on nowadays with the internet, having databases and middle tiers and load balancing and the client and the browser and so on. There's so much stuff going on. What exactly are you trying to test? And you need to focus on that. What we are trying to test is that there is a request leaving your machine going to a middle tier server somewhere. And we need to measure how long is that request taking from your machine to get there. And then we need to find out also how many bytes, whether it's bytes or kilobytes, leaving your machine and getting to that server. And then from that point on, we need to find out the response that is coming back from the server to your client. How long is it taking to get back to your machine, and also how many bytes and kilobytes are coming back. So there is, of course, 100 other things that you can measure, but these are really the most important thing that you want to find out, something called time to first byte and time to last byte. It is not, in my opinion, it's not very important actually how long the browser like Chrome or Firefox or IE is taking to render your stuff. This is something you don't have a handle over because you're not going to be able to test these browsers. That's not your job to test these browsers. So some of them might be faster than others in rendering the response once it comes back. What you can actually measure using these load testing tools is how long the response as far as first byte and last byte come back from the server, and that's extremely important as well. Also, the kilobytes are very important. Let me give you an example in a real-life scenario, folks. If you have one person hitting a specific server, and it's coming back in, like, let's say 1 second, and then that person is hitting the same kind of pages on a web application, and 90% of the content is based on JavaScript and CSS, and they are all the same. You'll end up seeing, for instance, in some of the numbers on any tool that you use, that they are spending the time bringing back the JavaScript and the CSS every time to visit a specific page. A load testing tool should be able to tell you that there is a problem there by showing you some numbers that points out that there is no, for instance, compression, there is no caching on the server, there is no caching on the client, maybe the view state is too large that is coming from some of these applications. These are the things that you want to actually concentrate on, because once you have 100 or 200 people hitting your web application, you do not want to actually end up downloading for every single one of them 500 kilobytes of CSS or JavaScript every time. There has to be some caching and some optimization to the system to scale the system up. And we will talk about that later on to show you how you can monitor that stuff really easily as well. All right, let's talk a little bit about scalability, which is a little bit different than performance. They're all related, but scalability is the ability to handle additional workload. This is not based on the one-person scenario testing the site. All right, this is usually, I think of always the performance testing is the R&D scenario. Somebody is writing the code for your web application and they're testing on their machine, and everything works well on their machine. But once they send it to QA and they start hitting it by 10, 15, 100 people, they start seeing some serious problem with the application. So that's a scalability test that you will need to concentrate yourself with. So the ability to handle additional workload without negatively affecting performance, and by adding processor power, memory, and storage, which is mainly hardware. This is something that used to always come up during the years. A lot of books have been written about scalability, and the one thing that is common between all these books and white papers and the big guns in the world of testing, they always say, like, if you need to scale your system, you need to throw hardware at it. If every time you want to scale your system, you have to change the architecture or change some software code in your application, the architecture was not correct to start with. In real life, of course, you can do things in software to make things better, but in reality, throwing hardware should scale the system if the architecture was correct by having more load balance servers in the middle. Scalability comes after the performance has been measured and fixed. That means you cannot scale a system if it doesn't even perform for one client by itself. The last one in here is a major issue, folks, which is the goal is linear. The more resources, the farther the workload will go. If I actually have 2 servers in the middle and I can actually have a maximum of 100 people on it, I'm expecting if I go to 3 servers or 4 servers, hopefully to go, it's not going to go from 100 to 200 just because I added 2 servers. It doesn't work like that in real life. But I'm supposed to go a little bit higher. Maybe it's not going to be a straight line in the graph, but I should go maybe to 160, 170 users or virtual users coming into the system. The worst thing that can happen is that you have 2 servers with a maximum of 100 people, and then when you add 2 more servers, you go up to 110. There is something seriously wrong with the architecture that by having so much more power, almost double the power, gets you only 10% more scalability on the system. So you have to think about that as well. Let me show you, for instance, these 2 graphs in here to explain the difference between performance versus scalability. The red line in here, folks, is very important. That means we are not really fishing. We're not actually expecting the test to tell us how far the system will go. This is something that management in every company will have to set before everything starts. That means a company will say, our response time will need to be a 1 second for all these pages. So you are going to have to set the goal really for how fast your website will work. And now we're going to start testing with 25 users, with 50 users, with 75 users, and it looks like we're doing fine. I mean, it's getting, of course, with more users coming in, it's taking more time between 600 milliseconds, 800 milliseconds, and then we're going to get to 100 users, and anything after 100 users, the page is taking a lot longer than our threshold, which is 1 second. So we need to find out what we're going to do to fix this. Hopefully, adding more servers, like here we have 1, 2, 3, 4, 5 servers available to do load balancing on. You will notice here from the graph, this is not a very good graph, by the way. It looks like I will be able to go further by having more users, 100, 120, 140, but after the 3rd server, I'm going to be stuck somewhere around 150 users, and then the line will go deeply in decline. That means something is going on in here. Maybe I wanted to go a little bit more straight line than just going completely adding of every server will add you maybe another 10 or 15 different users. Something is not making sense here. Maybe it has to do with caching. Maybe it has to do with the database bottleneck is causing a problem. But these graphs will help you understand what is your bottleneck. 3 servers, 4 servers. Obviously, adding anything after 3 servers is not helping me much, so I need to make a change in the system to make this go further. What is the benefit of? Yes, go for it, Sergey.
Yeah, let me throw a couple of questions because I think this is a very important illustration, and as we all know, good pictures give answers and then create some more questions.
Excellent.
So first of all, I wanted to point out that with most load testing tools, the response time versus users, it's a fairly standard graph. So you would run an experiment increasing the number of users, and you would measure your response time, average response time over some, I guess, selected time window. So that's fairly standard. With supported users, that's a synthetic graph because essentially it's running the same experiments over different infrastructure, one that has 1 server, the other that has 2 servers, and so forth, or maybe approximating, and seeing where, at what number of users your system hits the acceptable threshold for whatever the performance metric is, or performance metrics are. So this is something that the testers will need to come up on their own. But there's, I think, an even more important question behind this, which is once you start scaling, you think about adding more hardware, and in many cases, the production environment for software has the hardware scalability, but the test environment won't necessarily have the parallel scalability to production. And very frequently, people test in some sort of a mock-up environment with the test environment, and they want to know, can I approximate what my production environment is actually going to behave like? Can I make any conclusions regarding my system after tests internally and say, well, considering I had this deployment infrastructure and I've seen these numbers, with my production, if I double the infrastructure, I'm going to have, I don't know, twice the capacity. So there were quite a number of questions about this discrepancy between test and production environments. And could you elaborate on what it actually means for testing?
Oh, thank you for asking that question, Sergey. That is actually a religious question that happens all the time. Unfortunately, whenever we go to companies that want to do this seriously, they end up not really talking about it seriously, which is they do not want to mimic the production environment for QA to test on. And I believe that's a major problem in the industry because of budget reasons or whatever. But the reality is I am not a big believer that you can actually mimic a system on a smaller scale to find out how it's going to work. If you want to do this seriously, QA has to have exactly the same kind of hardware the production will be running on to be able to test on. Otherwise, there is no way you can actually get the correct 100% understanding of what's going to happen in production. How can you run something on a 2 CPU with 8 gig when the production is running 8 CPUs on multi-load balanced servers with 16 gig of RAM? It doesn't make sense. And I notice this always comes up in questions in training, for instance, or in consulting. How can we small scale the whole thing and mimic the same test? It just doesn't make sense in my opinion. If you want to get the real test, you have to run the same kind of environment that your production system is going to be running on. There is no mimicking in that situation as far as I'm concerned. Does that make sense, Sergey? Do you have any other questions about that? Because I know this is a very important subject.
Yeah, it does make sense, and I sort of expected the answer. So it just means that you could fake the results in some sense on a test system, but really to sleep safely, you would need to really create a mirror of the production environment and test there, or just dedicate some windows, maybe in I don't know, during the night or whenever, to test the application exactly in the environment that it will operate on. But there's also an even more subtle aspect of it, and I wouldn't dwell on it too much, but even if you have a complete hardware replica of your production environment, there could be software configurations that may affect its performance. So you need to make sure that all the services and I don't know, the ports and various other things are configured the same.
Yes,
did you have any experience with that?
Oh yes, we had actually a company that bought several Dell computers as a servers, and they were identical in everything, but IIS, for instance, was configured differently on the two machines, and they found out that in QA everything was perfect, but when it went to production, there was a major hit. I mean, several seconds delay on initialization, and that's because of one of the 100 different settings in IIS. So I would recommend always to find out a way to duplicate exactly the same environment, not only hardware, but software-wise regarding the installation of the Windows Server, if you're running on Windows. And also the IIS settings have to be identical with the application pools and everything that you need to make sure that everything is working identical. Otherwise, you're really not testing apples to apples between the two machines.
Thank you, Lino.
All righty. Let's move forward and let you really get a look into the benefits of measuring. Why do you want to measure actually the load testing or the performance testing and so on? First of all, the SS production readiness. Predict resource requirements. If your machine will work much better on an 8 CPU machine with maybe 8 gig of RAM, you want to find this early. You don't want to actually make these changes after the fact. Determine capacity of the current infrastructure. Compare the different system configurations. Very, very important piece in here, folks. Verify the application meets desired performance requirement within resource constraint. All right, you don't want to say test something with a major amount of resource, but you know you're not going to be running that in real life. You're going to be running on something a lot smaller. So why waste the time doing something like that? Assess adequacy of the software. Determine performance impact of the specific software changes. And compare current and desired performance characteristics. These are software pieces that you can do on your side to make sure the software is adequate for what you're trying to do. Finally, improving the efficiency of performance tuning. Analyze application behavior at various load levels. Maybe your application will work very well under 100 users, but for some reason, as soon as you get to 150 users, the performance is really bad. And you want to find a tool that will give you this information right away. And it might not have anything to do with the application itself. It might has to do maybe with the connection pooling in the database in Oracle or MySQL or SQL Server, that the connection pool was set to 100. It means anybody visiting after the 100 have to spend a lot more initialization time to create objects in memory and so on. So it can get a lot more complicated, and you might not see any difference. What happened after 100 users? My application is still compressing, is still doing caching, everything is good, but the connection pool to the database might be the problem. There's so many things that can go wrong in a load test, and you need to identify these bottlenecks. Are they in the server itself? Are they in IIS? Are in the database? Is it the caching? Is it the client? Is it the injection of AJAX maybe from the server to the client that is causing a problem? Is it a SOAP call, maybe an HTTP SOAP call that is causing this problem because of authentication? There is so much stuff that can happen that will bring a load test down. Part of it, we're not going to get into that, but there is multi-threading. I mean, remember, some browsers will allow only 3 requests to go at the same time. So one of the requests has to come back with a response before the 4th request can go out. So all these things have to be put in mind when you're trying to test your application. Finally, provide information on application speed and scalability prior to release. The management team, whether it's QA or R&D or the product management for a new company, have to have a document that gives them real data. Real data showing, like, if we have 200 users, this is the performance they're going to get. If we have 500 users, this is the kind of performance they're going to get. So when somebody complains later on that they are getting some really bad performance on your web application, for instance, you will need to take a snapshot of what the system was doing at that point to find out if we deviated away from our spec for the scalability of the system. Does that make sense? Now let's talk a little bit about what to measure for performance. I'm going to have this slide 3 times. 1 for performance, 1 for resources, and 1 for scalability. What do you want to measure? There is something very well known in the industry called time to first byte. TTFB, the time to first byte, folks, this first byte they're talking about is the first byte, the response from the server start going out back to you. That is the first byte they're talking about. Because once the request is being sent from your machine to the server, we want to find out how much work that the server has to do before it starts sending responses back. So the time to first byte is being measured and calculated as soon as the request being sent and when the first byte is starting to come back from the response again. So if the time to first byte is very long, that means there is so much stuff that has to happen on the server for initialization, for database, for whatever it needs to do to actually start responding to you. That's why a lot of people nowadays, when they create web application, they are trying to do a lot of AJAX-y stuff. What does AJAX have to do with the first byte? Because when AJAX is introduced in any web application, for instance, you will end up sending the page or the first byte really early. So you're going to get some very good performance here because the entire site will start rendering right away. The first byte will come really fast. But it's actually not totally true. What's happening is they're sending the minimum amount of the page to send the response, while the AJAX call is still working as a JavaScript callback on the server, and they will start injecting HTML into the page later on. So it's kind of really tricking the user to start seeing things right away instead of giving them a white page while you're doing things on the server. So AJAX can help a lot with that. The second piece is total page load time, and that's usually called the the time to last byte. That's very similar to the first byte, but this one, how long did the entire response take to come back? And this will be very important, for instance, to measure how much caching, how much view state, how much JavaScript is coming from the server to the client. So between these two numbers, you can do, of course, the calculations, and a lot of tools out there, and one of them, of course, is Load Complete from SmartBear, will let you know how much data and how much time is being spent from the first byte to the last byte. The last one in here, folks, is actually pretty much a religious thing. So I'm going to put it in here, is the page load time above the fold. This, for me, for instance, I don't expect this to be part of load testing at all, to be honest with you. What does this mean here, folks? This has to mean about the response coming back from the server. How long does the browser take to render this data? Remember, folks, we are not going to be testing Firefox. We are not going to be testing Chrome or IE. That's not our job. So I don't want to make the rendering time of the browser to be part of my test, because there is nothing I can do about it. If Chrome takes a second and a half to render all this JavaScript, there is not much I can do about it. So what I want to concentrate on is what I can actually affect, which is the request and the response going back and forth between the client and the server. Some people will say, like, well, this is very important. I mean, it's part of the experience. So I want to make sure that even if I bring everything back, if I'm running in Firefox, IE, or Chrome, or Safari, or Opera, or any of those, I want to make sure that the experience is still it's pretty good. So you might want to test this, but in my opinion, when you start talking about the page load time in here, folks, that has to do with functional testing, to be honest with you. That's not a load test. You are testing the browser now on your client. You're not testing the load going back and forth. So put that in mind as well when you start thinking about measurement for performance.
So, Lino,
Go for it.
I guess that's a comment for the audience as well. Since this is, as Lino said, a religious issue in some sense, if somebody from the audience has comments, or as a matter of fact, other questions, even though we've gotten a lot of questions a priori of this webinar, which allowed us to structure a presentation, I can understand if during the real time some folks may have more questions. So please feel free to submit them using the panel on your webinar control widget. And then as we get them, we'll either answer them offline if they're very specific, or we'll include them in the final Q&A at the end of the webinar. So basically you say, in your experience, the simple quantitative measures related to the packages that the server sends over the wire are really the ones that people should be looking at for analyzing performance.
That is correct, because that's the only thing you have anything to do with. That's the only thing that you can actually change by maybe reporting a bug to R&D or something. Other than that, you are not going to really change the behavior of Chrome or Firefox or IE. You can only make changes to your application to make it faster by compressing the data or caching it or changing the connection pool, but you're not going to change actually the rendering speed of the browser itself. Does that make sense?
Yes. Oh.
All right. So the next portion is about how to measure for load testing. We already talked about what to measure for performance. For load testing, there are three things that are very important, folks. One of them is, of course, the user load. People are not going to go from 1 user to 1,000 users in one step. That is not a realistic test. And I know a lot of tools out there will allow you to actually just test with 500 users or 1,000 users, and poof, immediately you'll have 1,000 requests being requested at the same time. That, of course, is not a realistic test. In a realistic test, you want to be able to trickle in users every second or every couple of seconds. So you can go from 1 to 5 to 10 to 20 to 30, all the way to 1,000 if you want to, or even more. But you need to trickle them in to mimic a realistic test. Otherwise, you're going to get the server shock, we call it. The server shock is that by having 500 requests coming in at the same time, that does not make sense. You might want to run this test to see how the stress test will work. If that ever happens, having 500 people, if you're maybe Amazon.com or eBay.com, and you want to find out what happens if 500 people come in at the same time, that's a stress test, and it needs to actually handle that gracefully as well. The other measurement is the request per second. We need to find out the math between the request per second that is coming in on the server. Alrighty? A lot of the tools out there, of course, Load Complete is one of them, will give you this math right away by recording a test. It will show you the request per second coming in. The third one, which I consider to be the funniest one, to be honest with you, because I've seen a lot of people get a lot of errors during their scenario that they're recording or testing. And they actually don't pay much attention for the errors, but they get some very good results. The website is screaming fast. But unfortunately, they don't pay attention that it's screaming fast because a lot of the requests are coming back with a 500 HTTP 500 error, and it's coming back really fast, right? Because once it knows that it's a 500 error, the response comes back with a 500 error, and they're very happy to know that they came back in like tenths of a second. That's great, but unfortunately, you're getting so many errors, so the error came back very fast. The response did not really come back very fast. So if you have a tool that does not dig in to tell you exactly what happened on the wire, to show you that there is a 500 error coming back, or a 404, or a 300 for authentication, for instance, you want to make sure that the test is coming back with 200 OKs on these responses to make sure that the system is behaving correctly. Again, so you might be getting...
No, that's, I guess, a very simple check that some of the tools either don't do or some of the users ignore, right? So it's a matter of... well, a priori looking for that type of information, but also it's a matter of how a tool would present that information.
Yes.
Interestingly enough, we had a customer in the past years when Test Complete featured load testing, who've been using Test Complete in exactly this manner, ignoring the errors corresponding to the different status returned from the server, and her application seemed to be working fine until they realized there were functional errors on the load. So
yeah,
it is a real story.
Yeah, that happens a lot. I mean, there is some other tools out there in the market today that do not concentrate on the speeds. They only concentrate on the bytes going back and forth and the millisecond going back and forth. So if the error comes back, that is still a valid response, the error. So if you don't know that that's an error, everything will look like it's working correctly. All right. The final one is about measuring resource testing. And that's also very, very important, folks, regarding dealing with the CPU. You do not want to have like maybe 10 or 15 people hitting your web application and your CPU is always at 98%. That means you're putting some major strain on the hardware. Is that something you can fix software-wise, or do you really need to add more CPUs or get bigger machines to actually handle your web application? Also for the memory. If the memory is always, your application is taking like 200 megabytes as a footprint in memory, you want to make sure why that is. So you want something to monitor these things for you. The final part is the disk and the network. Are we doing a lot of access to the disk all the time? Remember, folks, this is the slowest thing in any computer in the world. Doesn't matter if you're running Windows or any other platform. This is the slowest thing that can happen on a machine. If your web applications keep going back and doing temporary things on the disk all the time, that is not going to scale very well when you have 1,000 people hitting your website. The network, of course, is very important as well to find out the throughput on the network, whether you're working on an internal website or an external web application. I always find it to be that the disk has to be on these machines pretty fast to make sure that any communication between the web app and the disk for temporary scenarios will not be the major bug down. If you would ask me based on experience, for instance, I find this to be the #1 reason for slow websites, believe it or not. So this is something that you can actually cause the system not to use that disk caching a lot during heavy loading on the system itself. Alrighty. I want to actually talk, before I actually maybe give you a demo, about 3 different kind of tests that you might be interested in as well when it comes to performance and load testing. There is something called smoke test. A lot of you probably on the call today are familiar with functional testing and having a smoke test, which is not an extremely long test or anything like that, but you want to just certify a specific build of an application that is not dead on arrival. So you want to make sure that even with 1 or 2 users hitting your web application, you are not going to bog down the entire system. So a smoke test is very important to have available that runs every night, maybe at midnight, using an automatic build tool or something like that. I recommend for every team to always have a smoke test for their web application, especially for load testing as well. The capacity test, this is something that a tool like Load Complete or any other tool in the industry can help you understand what are your limits. And it's important for you to know, you do not want your customer to tell you what your limits are. So the capacity test, you can keep running these tests to find out, really, we go down to our knees after a specific amount of user or a specific amount of load on the CPU or the memory and so on. And you need to have this data available for you. The final one, which is definitely a lot of people ignore, which is the endurance test. Folks, if you hit a web application with, let's say, 500 users for like 2 minutes and it works, that is not the end of the story. You want to always set an endurance test to run maybe for 24 or 48 hours. The fact that your web application has been able to perform well when 500 people hit a couple of pages for a couple of minutes, that's great. The fact that actually it will run these 500 users for the next day or 2 simultaneously, we want to find out if there's a small leak in memory on the web application that with time it will not bring the whole server down to its knees. Same thing with the caching. We want to find out when the session expires, maybe after 24 hours or whatever it is, what is the result of that? Are we going to blow out the stack on the server for all this application, whether it's written in PHP or ASP.NET or Flash or Silverlight? It doesn't really matter. the endurance test is very important. Don't run your test in an hour or a couple of minutes. You want to make sure the test runs for a longer period of time. All righty. The testing tools available out there that you can actually play with. I mean, there is open source, there's free things, there's so much stuff in the industry you can do. There's hundreds of different testing tools available today. For instance, people use Firebug and YSlow. If you have not probably heard of YSlow, I know everybody heard of Firebug, but YSlow is a tool from Yahoo that hooks up to Firebug inside of Firefox, for instance, and it will give you a full-blown grading to tell you what you're doing wrong maybe on the server. Maybe you're not caching. Maybe you're not compressing the data. Maybe you're using too much view state. These are great tools to be able to show you that kind of stuff, and they're all free. The Chrome Speed Tracer. Again, you can include the Speed Tracer coming from Chrome in the Chrome browser itself, and it gives you a very good visual to show you about the request and the response coming back. Even in IE9 now, when it shipped, has developer tools built into Internet Explorer 9 that you can see almost the same exact thing like the Chrome Speed Tracer. You can see the packets going back and forth. We use, here at Falafel, for instance, we use also another tool called Fiddler. You can download all these tools for free, and Fiddler will show you the packets going back and forth. Of course, companies have been along for a long time. HP, the Mercury Load Runner is available. The Perfmon that is available with Windows, for instance, that you can actually do performance monitoring on the CLR from .NET or the SQL Server databases or the ASP.NET or IIS. There is tons of different things that you can monitor using performance monitoring. These are free tools as well. And of course, now we have SmartBear actually hosting this webinar today, so we'll say that Load Complete is available from SmartBear, and it does a very, very good job doing these kind of things as well. But with a small little search on Google or on Bing, you can see hundreds of different tools out there. We happen to use Load Complete here for our customers for a while, and before that with Test Complete Load Testing, and it works extremely well identifying the bottlenecks in the systems as well. So maybe this is a good time, maybe, Sergey, to show a demo in Load Complete to go through the points.
I thought that considering that we've gone through so many concepts, it will be appropriate to show just kind of a few slices of how these things can be configured, measured, both from the point of view of real-time analysis and a little bit more detailed. There were also questions about the overhead that server monitoring may impose. Maybe you could cover that as well as you explain how these numbers come about and talk about different counters. And since I know what we were going to be using for a demo, there was a question, well, simple websites are fine, but what does the tester need to do, or what implications load testing will have if rich internet technologies are involved? For example, Adobe Flash or Microsoft Silverlight, because that's obviously not as straightforward as just testing basic HTTP traffic. So if you could hit on some of these questions in passing, I think that'll be a great final demo.
Excellent. Thank you, Sergey. So this is a great question, and we actually, you and I got this, if you remember, a couple of weeks ago when we were in the Adobe conference in Los Angeles. A lot of people asked that question: how can we actually do load testing on our Flash application or Air application? And also at Microsoft, we were asked how do we do load testing on Silverlight application. I want to actually remind everybody that these technologies are client-side technologies. The Flash technology and also the Silverlight technology, these are all client-side technology. So when you request it, the whole application comes down to your client, and it will continue running on your client machine. There is no communication like in HTML and PHP and ASP.NET. It's going back and forth. It is true, though, once you get the application down, whether it's Flash or Silverlight, every once in a while you can make a call back to the server to request more data using SOAP or REST APIs or whatever. That will definitely be monitored by Load Complete. But if the whole application comes down and you have no need to go back and get any more data, there is no more communication to monitor on the wire. It becomes really like exactly running a regular Windows application on your machine at that point. But it will monitor any conversation going back and forth. And the nice thing about Load Complete, for instance, like you see this demo we were showing a couple of weeks ago in Los Angeles during the Adobe conference, is that it understands that there is an application type of AMF, which is the object types actually inside of a flash, for instance. So the load complete will understand this kind of information. But it doesn't have to be like that. It doesn't have to just understand AMF application or Silverlight application or regular HTML or HTML5. Notice I can also monitor SOAP, calls going back and forth. Everything that's going on the HTTP pipe will be monitored automatically by the system. I'm going to actually leave this demo as is. I'm going to do something else here for a quick second just to give you an idea. There is a recorder here built inside of Load Complete. If I click on this recorder, I can actually create, for instance, let's give a Lino scenario on here, for instance, and a test. We'll call it Sergey. That is my test. All right, I can actually choose which application I would like to monitor, for instance. I can say, let's go to HTTP. I will say www.smartbear.com. Of course, SmartBear application right now is an ASP.NET application. It's a content management system website, but it doesn't really matter what that is. What I wanted to show you is that you can put the monitor on your local machine, what I'm running right now, or you can also put it at the smartbear.com embedded on that server where it's serving that, or you can put it on both of them. What's the importance of that, folks? Well, in the beginning, I'll say it's not very important because I'm actually monitoring the requests and response. So even if I'm monitoring my machine here, the local machine I'm running on, I'm going to be monitoring every request and response going back and forth. When would it be important to actually put the monitors in the right place? If I want to find out how the CPU, for instance, on the SmartBear server is behaving, how the memory, then I need to actually monitor the server over there. But if you're only interested about the requests and the responses and the kilobytes and the millisecond going back and forth, to be honest with you, you can have the monitor on even your local machine and you'll still get pretty good numbers. It's only when you're going to get into counters and performance counters on the server for the memory on that server and for the CPU and for so on for resources, then you need to actually be concerned about where that will be. I'm going to actually choose here, for instance, Internet Explorer or Firefox or Chrome. Any of these browsers can help me record the packets going back and forth. It's not important really which one I start with unless I want to actually mimic exactly the same throughput coming from these browsers. Let's say, for instance, I'm going to use Internet Explorer. This button in here is a troublemaker, alrighty? Without it, we will have problems. I'm glad this is available in a product like Load Complete. I know other product has it as well. It's to clear the browser. If you have already visited smartbear.com before you record your test, some of the images on SmartBear and maybe some of the JavaScript have already been cached in temporary files on your machine. So there is a chance that Internet Explorer will not bring them back. That means the recorded session that you're going to do in here will be missing some requests. Why? Because it never needed it, because it's going to use the one in the cache that has not expired yet. So I recommend to always clear the browser data so that your recorded session will have all the information about the images, the JavaScript, the cookies, everything it needs to get from the server has to be recorded. Otherwise, this will not be a realistic test as well. Let's go ahead.
Yep.
And click on the record and let's see what the system does. Recorder available in here. And there you go, the system is available. Let's just click on one thing really quickly. Now, let's say, for instance, we'll go to the products page and we'll click on automated test, for instance. Alrighty. Once I do that, it's actually going to a completely different request, and I'm going to stop the recording. This again could have been a Flash application, a Silverlight application, HTML5, anything that would allow us to do this back and forth. Alrighty. So let's go ahead now. It's actually saving all this information, and you'll notice here that I have a brand new scenario called Lino available right there, and there is a test called Sergey. In the Lino test itself, all the pages that were visited and all the requests, I can see each and every request, and I can see the entire getter and the response that came back from the server. If it has a 301 or a 302 for moving permanently or temporarily will be available in there. And I can see all this information inside of here as well. I can see CSSs. One of the things that you need to think about, folks, is that I have, for instance, Skype running and Windows Live Manager running. The funny thing is sometimes you'll come back in here and find out that there is Facebook have something available in here. That's because the pipe is listening on the entire HTTP pipe going back and forth. So sometimes you'll have to come in here and delete some of the requests that have nothing to do with what you are expecting to see inside of your test. So it's important to come in here and take a look at these things as well. You can always run this test already, or you can actually take a look at the test that got created for you for the Linux scenario itself. So I'm going to take a couple of minutes here, if you don't mind, explaining this most important line in load complete. This is really the most important line. First of all, I'm going to create a group name. Let's call it, for instance, Sergey. Alrighty, and I'm going to say I would like to mimic one virtual user running this Linux scenario. Again, we have a lot of different scenarios in here. And I'm going to tell it where do I want to run it. Maybe on my master machine, which is this machine in here. I have the choice, of course, of adding more machines. Maybe I have 4 or 5 different lab machines with their own IP addresses that I want to make them part of this entire test. The important thing, folks, is you don't want to run 1,000 different virtual users on the same machine. You want to split it up between different machines to have a more realistic test for sure. Another thing in here is the browser. Notice I said the browser is not important because I'm actually using the request and the response coming back. So why is it asking me for the browser in here? It's just asking to mimic what exactly is the throughput going to happen. You can mimic an Internet Explorer 5, 6, 7, or 8, any of the Firefox version. You can see the Opera, Pocket IE. I also can say smartphone. I want to find out how will the system behave if I run the entire Linux scenario that I recorded, but as if it was coming from a smartphone, not from a regular desktop, so I can see how that stuff happens as well. If you leave it as the recorded, it will use the same throughput that you use regularly from Internet Explorer, because that's the one I used during the recording. The start delay will allow you, for instance, how long do you want the system to wait until this one user gets created in memory and start bombarding the server. If you see 0 millisecond, as soon as the test Sergey starts, the Sergey test will automatically start bombarding the master from the master server right away. I can come in here and say 1,000, for instance, and that will wait 1 second after the test starts for this one user to start bombarding the server as well. Finally, my favorite part is the connection speed. Don't count on your load test. Everybody have an expensive pipe, fat pipe to actually send this back and forth. So if you are working for a company that have a T3 line or a fiber optic lines, that's great for you. But other people that do not have that kind of pipe, you want to find out how their experience is going to be. So you can mimic actually the entire scenario of Lino running on a dial-up 56K or a 256 or a 766 cable, DSLs, whatever. You can do any of these things in here, and the system will give you the correct numbers based on limiting the throughput going back and forth for the request and the response. This is a very quick way of doing that. Notice I can add another test, and he will say, let's say 100 users. I can choose a scenario in here for Lino. I can actually running on my machine master and so on. So now when I say run, if I say run Sergey, for instance, in here, it will run 1 virtual users immediately, and at the same time will also run a 100 virtual users. So there is 101 users will be created immediately. If I come in here and say 1,000, 1 users will be created. A second later, 100 users will be created, and memory will start bombarding with the same exact request going to the server right away. One of the things that you can do as the bottom, as you can see in here, you can do a continuous load. You can do a stepwise code. So I can say start with 1 user and and add a couple of users, maybe every 2-3 seconds. So you can trickle in users, not just create 100 poof right away. That doesn't sometimes make a lot of sense. So you can trickle them in if you would like. There's also a way to do a custom shape, so you can actually double click in here and choose exactly how you want to do this. So I can actually go something like this, say like have a heavy load, then go down, and then go have a heavy load. So it's very fancy stuff. Again, we would need like another 4 hours to explain all these things, but the system here will allow you to do something like this. And I know a lot of other tools in the market too will help you with that. I want to focus on this webinar to show you the things that you can and cannot do really using load testing in general. For instance, yes, go for it.
Sorry, yeah, I'll need to interrupt because we are coming up against the time limit. We have a few very good, outstanding questions that I still would like to cover. So in terms of, I guess, testing rich Internet apps, we've covered that subject. We wanted to show some graphs about metrics and how to really track them, but that should be self-evident. I'll probably insert some questions right now from the audience, since we promised to.
Absolutely, go for it, sir.
Stick to this format for the webinar. Even though I have to admit the questions that came in were already included in the original set, but I think they're important enough that we go back to them and cover these matters. So the first one, how to load performance test a web application hosted in the cloud. Right. So we talked about scaling hardware, right, on premise with some load balancers. But with respect to cloud-based apps, there are some automatic means of adding hardware, I guess, with certain subscriptions. So does load testing for apps in the cloud really differ that much from testing apps that are hosted on your own hardware? And what would those differences be?
That's an excellent question, and everybody knows now with the cloud hitting really hard in the industry, that would be a major question, definitely, that will always pop up. Notice here, for instance, that the Adobe example that we had actually at the conference, we are actually running this against an Amazon EC2 cloud server. So the host here is running in the cloud. So there are two things that you can do with the cloud, whether it's an Amazon EC2 or the Windows Azure cloud, for instance. We have tested this with both. You have to understand that if you use a dynamic way of using the cloud, it means you do not have really power over choosing where the system is going to load balance to. And that will make it very difficult, of course, for you to deal with that. Or you can use a static way. That means you can get the IP addresses of the 4 or 5 machines that you can load balance to, and you can put an agent on all of those, and now you can monitor them exactly as if you have a full access to these machines. So some cloud systems will not allow you to actually have full access to these machines. Some of them will not give you the IP address, but nowadays you will be able to say, I want to have access to the machines because there is something I want to install on them in case you want to do load balancing. And that's the best way to do it if you're going to do that with testing, whether from Load Complete or from any other tool as well, because you don't want it to be load balanced on a machine that you don't have access to monitor in case it does that in the middle of the test. Does that make sense?
Yes, I actually want to add that conceptually, most of the types of tests that we talked about still make sense, because the stress, well, even the stress test, because in some sense you expect your system to scale according to the number of users, and you want to have some sort of analytics running so that the machines are added as appropriate. But you want to verify that it actually happens in real life. So you would still want to run a load test against the application and see how it behaves upon increasing the load in some sort of gradual fashion. That the expectation would be that your response times should be consistent. And then the error may be not because the machines didn't get added, but for some other reasons, but it's still possible that there would be a performance error, right? There could be functional errors as well and a host of others. So in reality, the more I think about it, the less difference there is testing of web apps hosted by companies or in the cloud. It's just the expectations may be slightly different, but all the same tests apply.
That is correct.
Speaking about architecture, there were a few questions about web services because either a server may engage third-party web services in composing the actual response, or maybe even a client with JavaScript could address third-party web services. So how will these things be tested in the grand scheme of load testing?
That's an excellent question as well. We get that several times lately. I want to remind everybody that SOAP has been available for a long time, almost 15, 16 years now, and it served a purpose, definitely, to make remote procedure calls between different servers. And in the beginning, it was based on HTTP. And 90% of the implementation of SOAP is still based on HTTP. That means that Load Complete, for instance, or any other tool that does load testing, will be able to monitor the request and the response for all these SOAP calls going back and forth between a client and a server. If the system uses a different protocol than HTTP, then there are other tools that will actually monitor specific TCP/IP lines and so on. But the majority of the SOAP calls are using HTTP or HTTPS for SSL security, for instance, and Load Complete will be able to help you definitely with something like that as well. Nowadays, a lot of people move to something like REST calls just because of the asynchronous level of performance. A lot of people want to do mobile development, for instance, for iPhone, for Android, for Windows Phone 7, for the BlackBerries, and the SOAP doesn't work very well for that because some of these devices, if the call takes too long, it actually keeps the UI frozen, and they don't like that idea. So they move to REST APIs. That means you have full control of the UI while asynchronously the call is coming back. Even with that, it's still possible to test the stuff with Load Complete and these other testing tools. And I know Sergey maybe can talk about other products from SmartBear that actually specifically positioned to do SOAP testing as well.
Right. Yeah. Let me add a couple of things here. So as Lino said, some exercise of web service will be included in load test automatically just because these calls are captured. But the load on a web service, or a number of them, will be sort of apportioned only insofar as the original scenario exercises them. To load test the web service, you basically need to set up a separate framework. Load Complete, while it supports testing web services, it's not really a fully featured web service load testing tool. We do have a family of web service testing tools in the SmartBear family with SOAP UI and Load UI, which are open source tools, so they can be obtained freely, used freely, and they're very capable. And there is also a professional version of SOAP UI, which is a functional web services test tool, which offers a bit more capability. And there's going to be a pro version of Load UI just as well to be released during the first half of 2012. But again, that's a separate effort and very worthwhile because whenever possible, you would want to stress test parts of your system before assembling that into a whole, much like you would want to test functionally parts of your system before assembling the final product. Let me see if we have any more questions that came in that we haven't covered yet. Well, there's one specific question about load testing, but I think that's very important in the methodology, so I think we should call this out from Cheryl. After recording one test, which is kind of a typical flow, you record one test and then you replicate it to virtual users. How do you make your virtual users unique? Because presumably in real life, every user would behave somewhat differently, enter different search terms, come in with a different password, and so forth. So in brief, Lino, how would the tools handle that? Those that can, that is.
Yes, that's an excellent question. It's actually one of the best things about tools like Load Complete, for instance. They have the ability of loading data from an outside file like an Excel spreadsheet or a database or a comma delimited file and so on. So after you do a recording, you can set some parameters in your system in here to be able to change the flow. So even if you want to say 50 people to hit that same exact request, and actually modify this to load from an outside file or from an Excel spreadsheet.
I guess we have some sort of technical problems with connection to Lino. We're not in the same office.
Run this before in here, for instance, so I can show you. Hello?
Yeah, Lino, there's some breakup in the voice connection.
Oh.
So let me just summarize what the approach would be, and since we're past the hour, we should be sort of wrapping up the webinar.
Sure.
In principle, yes, what the approach is to take that scenario and apply external data to that. So if you have 50 virtual users that you plan to use, you can generate data, 50 different data sets, and use internal variables in Load Complete to attach different rows of that data set to different virtual users, and then Load Complete will run this scenario based on 50 different data sets. And it's actually pretty easy to do. There are wizards for doing that, and actually there are data generators as well that can sort of bootstrap your approach to this. But it's very important because you will have a different behavior of a server depending on whether all of your virtual users do the same thing, because there will be a lot of caching on the server side, and you may get overly optimistic performance numbers, versus 50 virtual users searching for different things, supplying different credit card numbers and so forth, because those would generate different threads in the background of a multi-tier system. So I understand there are tons of questions that still remain about load testing. We thank you very much for attending the webinar. Lino, it's been a pleasure to have you.
Thank you so much for having me, and thank you everybody for attending the webinar. Thank you.
We might consider actually writing 1 or 2 white papers featuring the questions and answers as were submitted, because they really cover a very broad spectrum of topics, and they all seem to be very useful and timely. So please stay tuned. And as far as the materials for this webinar, we will provide a link to the PowerPoint that was used and whatever other materials we can scrounge up, so that you have a reference to whatever was said or shown. Again, thank you so much for attending, and please visit smartbear.com for more information about Load Complete and other tools that we offer. Have a great day.